All right, welcome back. Today we're dealing with that gradient. And when you talk about the gradient, we also know it as the what? The slope of a line, or we can say the steepness of a line. Either we are going up here, or the slope could be going down, right? So in basic terms, we're simply saying that when we're talking about the gradient, we're now saying change in y values over change in x values. Let's take, for example, I've got point A and point B here, right? And then if I start at point B and I look, remember, it said change in y values, right? So now if I look at the y at point B, I'm at 3 here. And I look at the y at point A, I'm at 1. Now I want to know how much change happened. So I now move from 3 and going to 1. So now, in other words, I'm going to say 3 minus 1 in order for me to know how much movement happened. So that's when we come to the formula where they say yb minus ya. So m represents gradient, right? And then now we're saying at point B, my y was 3, minus comes with the formula. And then at point A, my y is 1. So 3 minus 1 all over. Then what else do we look at? We now look at our denominator says change in x values. So our x at point B is -1. So we say -1 minus, we've got -5, right? So we're simply saying that we are here at -1. Our x at point B is -1. And now how many times have we moved to get to -5? You see, we're going to the left like this on the horizontal axis, which is the x-axis. From -1 to -5, how much distance do we have? So now we say minus, open bracket, -5. 3 minus 1 is equal to 2 all over. Negative times negative, that's a positive. So we've got -1 plus 5, which is equal to what? Now we say 2 over -1 plus 5. If you punch your calculator, it will give you 4. Now we've got 2 over 4. And if we simplify it, it now gives us what? 1 over 2. So therefore, we can conclude that our gradient is equals to 1 over 2. That's how you get your gradient. So your gradient formula, you say yb minus ya, xb minus xa. If you are given line CD and they say find the gradient, you will say gradient CD is equal to the latter, which is D. You now say yd minus yc all over xd minus xc. That's how you determine the gradient. I hope it's clear enough. Now, from here, what we have spoken about, now we want to talk about what? The different types of gradients that you find, right? And the first type of gradient that we're going to deal with, what? Gradients of parallel lines. So gradient of parallel lines. Now, what are we investigating? Here we call this what? We call this application. We are now going to use our gradient formula to know more about what? Parallel lines. So if you look, we've got point A and point B and line C and point D there. So now line AB and line CD, they are parallel lines. Now we want to know, what do they give us? What do they tell us? So we now say gradient of line AB is equal to yb minus ya all over xb minus xa, which is equal to what? My y at point B is 5, so I say 5 minus my y at point A is -1, so I place it inside the brackets all over. My x at point B is 3 minus my x at point A is -5. So I open the bracket, I say -5 like this. Negative times negative is a positive. So here I've got 5 plus 1 all over. Negative times negative, positive. So I've got 3 plus 5, which is equals to 5 plus 1, 6 all over. 3 plus 5 is equals to 8. Now, there is a common factor between 6 and 8, which is 2. 6 divided by 2 gives us 3. All over 8 divided by 2, which is equals to 4. So the gradient of line AB is equal to 4. We have found it. Now let's go to gradient of line CD. We now say gradient of line CD is equals to yd minus yc all over xd minus xc. Now, my y at point D is 2, so I write 2 minus. My y at point C is negative 4, so I've got 2 open bracket minus open bracket negative 4 all over. My x at point D is 5, so I say 5 minus my x at point C is negative 3. I open the bracket and I say negative 3, which is equals to negative times negative, it's a positive. So I've got 2 plus 4 all over negative times negative, another positive. So I've got 5 plus 3, which is equals to 2 plus 4 is equals to 6 all over 5 plus 3 is equals to 8. Observe at this stage we had 6 over 8 and here we've got 6 over 8. So obviously it's equals to 3 over 4. So in conclusion, what do we conclude? Here's our conclusion that we're drawing. The gradients of parallel lines are what? Are equal. So gradients, we're now saying gradient of line AB is equal to gradient of line CD, because both of them are what? Gradients of parallel lines. And this information is very important. You shall see when we do the videos of what? Past exam papers. They can give you, they can simply tell you that, oh, line AB is parallel to line CD. And then here you're not given point A. Now they say that, hey, tell us determine the equation of line AB. And you are only given 1 point. But the information which they've given you is the fact that line AB is parallel to line CD. So in such a case, you have to what? Calculate here and get the gradient of line CD. When you are done, you now take that gradient and you use it to determine the equation of line AB. Why? Because you know that the gradients of parallel lines are equal, right? So yes, that's number 1. Now let's go to another type of gradient. We've got what we call perpendicular lines, like as illustrated here. So now we want to investigate to say what happens with the gradients of what? Perpendicular lines. Gradient of perpendicular lines. What do we know, number 1, about perpendicular lines? We know these are lines that intersect at a point, and where they intersect, where they meet, they form 90 degrees, like here. So here we've got line AB, and then we've got line DC here. And here it is indicated that there is 90 degrees, right? So what do we know? What we know is that when you've got gradients of perpendicular lines, you say gradient of line 1 multiplied by gradient of line 2. It should give you a product of negative 1. Meaning to say that when you get the when you determine the gradient of line 1 and you have determined the gradient of line 2, when you multiply them, they should give you negative 1. That negative 1 is confirmation that here there is 90 degrees. If you multiply and you don't get negative 1, then you must know the lines which you are having, they are not perpendicular lines. So what are we going to do now? In this case, we've got line AB, so we're going to say that we have to look for gradient of line AB. But observe, what is there? We already, from our previous question, here, on this particular line here, this line A, B here, where B, 3, 5, and A was negative 5 and negative 1. And here we've got negative 5, negative 1, and 3 and 5 at point B. So what are we going to do? I'm not going to waste your time by looking for gradient of line AB. I'm just going to tell you that gradient of line AB is equal to what? The gradient of line AB is equals to 3 over 4. I'm taking this answer from the previous questions. Just rewind or just go back a little bit, pause this video, go back, and you'll see that we found that the gradient of line AB was equals to 3 over 4, right? All right. So now what we need to calculate for is the gradient of line CD. So now we say gradient of line CD is equal to YD minus YC all over XD minus XC there, right? Now, my y at point D is 6, so I say gradient of CD is equals to 6 minus my y at point C is negative 2, open bracket, negative 2 all over. Then my x at point D is negative 4, so I say negative 4 minus my x at point C is 2, so I place 2 there. Now, I do this, negative times negative is a positive, so I've got 6 plus 2 all over negative 4, negative 2 is a negative 6. 6 plus 2 is equals to what? Is equals to 8 all over negative 6. And here, if I divide by 2, 2 is the common denominator. Negative divided by positive, I get a negative, and 8 divided by 2, that is equals to 4, all over 6 divided by 2 is equals to 3. Now, remember, in this instance, I found the gradient of line. I say, therefore, gradient of line CD is equals to negative 4 over 3. Now, I come and I tell the examiner, I'm now going to multiply the gradient of line AB multiplied by the gradient of line CD. I don't write is equals to negative 1 because I haven't found that. Right, so I just write this, that this is what I'm going to do. So now my gradient of line AB, it is 3 over 4. So I say 3 over 4 here, multiplied by my gradient of line CD, I just found negative 4 over 3. Wow, isn't this interesting? These two, they can cancel each other. These two, they can cancel each other. But I'm not going to use that method. I say positive times negative, I get a negative. 3 times 4, I've got 12. All over 4 times 3, which is 12. And negative divided by positive, it gives me a what? A negative. And 12 into 12, 1. 12 into 12, 1. So there we go. I got a gradient of negative. I got a product of negative 1. So I then conclude that, therefore, line AB is perpendicular. This is the symbol which you use to indicate that the lines are perpendicular. So line AB is perpendicular to line CD. And by doing this, I have proven that I have perpendicular lines, right? Good. Now, I hope it's very clear for everybody, right? From there, we are now left with two types of gradients. So the first one which I'm going to do, we are going to talk about the gradient of a horizontal line, gradient of a horizontal line. Now, here, the next two is very important. They are very important. Or to understand the concept, it's important for us to go back to what we said, right? We said the definition of what? The definition of, help me. The definition of what? The definition of gradient. We said that we need to have change in y values over change in x values, right? So here I'm going to name this point A, and that one I'm going to name it point B here. So here I said that A is negative 4, my x is negative 4, and my y is what? My y is 3. If I go to B, I've got x, which is what? Which is 3, and my y is 3. Now, remember, if I come here, I will now say that the gradient of line AB is equal to YB minus YA all over XB minus XA. Here on my gradient of AB is equals to what? My y at point B is what? My y at point B is 3. So I write my 3 minus. What is my y at point A? My y at point A is also 3. All over. XB, my x at point B is 3. Minus my x at point A is negative 4. Open bracket, negative 4. Okay. Then from there, if I say 3 minus 3, I get 0 all over. Negative times negative, that's a positive. 3 plus 4, 7. Now, observe here. You have got 0 over 7. And what do we know from our algebra? We know that the moment your numerator is equal to 0, you can't divide by something that does not exist. So our answer then, it becomes, therefore, our gradient for line AB is equals to 0. Why are we having a 0? Because remember, here we said that change in y values, right? Gradient is equals to change in y values over change in x values. Let's come here. When we went for the YB minus YA, our y was at 3. Our y is still at 3. There was no change here. That's why there is 0. So it doesn't satisfy the definition of an equation. However, on our x values here, we had 3 and we had negative 4. There was change. But here, there was no change. So the gradient of a horizontal line is equal to 0. You understand? I hope that this illustration makes you understand. Then now from the gradient of a horizontal line, we must go to a gradient of a vertical line. Vertical line. Remember, vertical line, we're now talking about going up and down. So we must also determine the gradient of a vertical line. So how are we going to determine it? We're going to use this particular diagram here. If I come here, let me just erase a bit this part. All right. Now, if I draw my line here, there we go. Now, I name this point B, I name this point C, right? Now, what's going to happen here? If you look at this, let's say this is 2. So, yes, we say that we have got 2,5 as our x at point B, right? 2,5. Let me write it properly. 2,5, and my y at point B is -3. Then I go to point C. Let's say here my x is equals to, it's still 2,5. But my y here, let me say it's 6. My y is 6 there. Now, if I come to my formula, it says that I must say gradient of line BC is equals to YC minus YB all over XC minus XB, right? So my gradient of BC is equal to, what is my y value at point C? It's 6, so I say 6 minus my y at point B is -3, so open bracket, -3 all over. What's my x at point C? My x at point C is 2,5, so I write 2,5 minus, what is my x at B? It's 2,5. Now, negative times negative gives me a positive. So now I say gradient of BC is equals to 6 plus 3, 9. So I've got 9 over. Now I say 2,5 minus 2,5. I get what? 0. In other words, observe on our x values, I was at 2,5 here. At C, I've got 2,5 here. There is no change. No change happened. Whereas under a gradient, what we have, we are dealing with what? Change. So here there was no change. Now what does our algebra tell us? The moment your denominator is 0, then you can conclude that the gradient of BC is equals to undefined. The gradient of line BC is undefined. And since we found that the gradient of line BC is undefined, what conclusion do we draw about vertical lines? We now say whenever they're going to ask about the gradient of vertical lines, then your answer will say undefined. This is how you determine this, right? Okay, so I hope that this video was helpful and it has made things to be easier for you. Now, on the next video, I'm going to be focusing on what? Past exam papers of paper 2, right? Whereby I will be now explaining about trigonometry. I will be explaining about Euclidean geometry, as well as analytical geometry. It's one thing to be taught this theory. It's another thing to see past exam papers. So you don't want to miss past exam papers. Why don't you want to miss past exam papers? Because I will be dealing with level 1 to level 4 type of questions, so that you can understand the trickiness and how you can mix certain concepts, because you're not going to be dealing with analytical, like here, for instance, whereby I'm now talking about undefined. If you forget your algebra, then you won't know that it's undefined. You might write 0. I know of certain other teachers of my students who have once told students that 9 divided by 0 is equals to 0, whereas it's not 0, right? So, once again, if this video was helpful to you, please do consider subscribing, share, like, and comment. Till we meet next time, cheers.